In this video, we're going to do an introduction to statistics. We're going to talk about a little bit of vocabulary, a little bit of what statistics is interested in measuring, and kind of go through that in this chapter. So first thing we need to do is define a few words. Let's start with the big word, statistics. So statistics is the science. Here, I'm actually going to zoom in a little bit. The science of collecting, organizing, summarizing, and analyzing data. And that's in order to either answer a question or make conclusions. So they might have some sort of specific question in mind, but they could just be studying it. And they'll form conclusions based on that study. The population is the group of interest. So the population could be adult females, or the population could be college students, or the population could be specifically students at OCCC. So the group of interest is the people that you're trying to look at. The sample is a subgroup of the population, because often it's difficult to be able to survey an entire population, so it's easier to work with a small subgroup. Okay, so a parameter is a numerical measure of the population, or numerical summary of the population, like an average or a percent, or a statistic. So a statistic is a numerical summary of the sample, or a numerical measure of the sample. Okay, so let's look at an example. It kind of uses a little bit of this vocabulary. Researchers are interested in how many people have been evicted from their housing. Draw a diagram of this. And in this diagram, we want to identify population, sample, and then what parameter and statistic would be. Okay, so since we're talking about people evicted, it probably makes sense to talk about renters. I know that there are people who lose their homes, but typically that's foreclosure. So we're going to go ahead and assume that they're referring to people who rent. So these would be all the renters that they're interested in who are renting. And that would then be our population. A sample would be some sort of small subset of that group. And for our sample, we'll go ahead and pretend that out of all the population, we're going to look at 350 renters. Now, that number at the moment is just kind of arbitrary, but there are ways that you kind of figure out how you measure how big your samples should be. Okay, so the parameter in this case, what we're measuring is, because we're interested in how many have been evicted from their housing, that would be measured as like a proportion or a percent. So the parameter here would be the percent who were evicted. So that would mean that the statistic is specifically the percent of the 350 who were evicted. So looking at our little subset of the bigger group. Okay, so a representative sample is a sample that represents characteristics of the population. And I'm going to go ahead and put the phrase represents important characteristics of the population. So it's important to kind of note that sometimes when we want to make sure our sample is measuring these important characteristics, we may have to weight our information to do that. So sometimes the data is weighted. I'm going to put that in quotes to represent our population. So for instance, let's say you're looking at a group of people from Oregon, and we happen to know that the majority of our population is white, and then the next biggest ethnicity is Hispanic. And when I look at my sample, let's say there's some more Hispanics in the sample than there would be in our population. That means then that I need to give more weight to the group that represents white, because it wouldn't be accurately representing the population. And that process we're not going to go into. I just want you to be aware that that does happen when samples aren't fully fleshing out the important aspects of the population that they want it to. Okay, so simple random sample. And actually, because these boxes are pretty small, I'm going to type into it. So here, let me go ahead and attach my keyboard. And I'm going to type into this first box. So a simple random sample is a sample that uses chance to select members from the population. All right. An example of this, and I'll come back and draw the picture in a second, is drawing names out of a hat. All right. That would be an example of a simple random sample. A systematic sample is choosing every, now I'm going to say it this way, kth individual, but like maybe I mean 8th individual or 20th individual. So choosing every kth individual from a population. So quick example, and then I'm going to come back because I'm actually not done writing that definition. So hang on, I'm going to come back and finish that definition. An example of this would maybe be doing a survey at a grocery store. I spelled that wrong, that's funny. Grocery store by choosing every 10th customer. Okay, now the first person that's selected, the first individual, is a number between 1 and k. In other words, they have to choose the first individual randomly. So in this store survey, if they're choosing every 10th customer, the first customer they survey has to be a number between 1 and 10. And ideally, you should be randomly choosing a number between 1 and 10. And that's the first person you survey, and then you start counting every 10th individual. That's kind of the idea. So to keep systematic sampling without being biased, you shouldn't be choosing the first individual. You need to be randomly selecting the first individual. Okay, stratified sample is first you break up the population. The population by a common characteristic that you're interested in studying. Then do a simple random sample of each group. And I'm using that SRS to represent simple random sample. So then do a simple random sample of each group once you've broken it up. So a great example of this is when you do a poll by political party, the party that the person is registered to vote for. Okay, that's an example of a stratified sample. Okay, so convenience sample is not random at all. It is done by convenience only. A great example of this is people who maybe are trying to do a poll in front of a grocery store or any store, really. The idea is that's not random. They're just asking anybody who comes up, and anybody who's willing to come take the poll, they're going to get their information. Okay, so let me go ahead and diagram these really quick. So let me detach my keyboard now. All right, so coming back up to simple random sample, visually, what we have then is our population. Just kind of draw a little circle here. There's my population. And we are randomly just pulling people random from the population. There you go. That's how our sample comes to being. For a systematic sample, here's our population. But we are systematically, so we have our first individual who comes randomly, but then every individual after that is going to have this kind of equal spacing between them as they're being chosen. Sorry about my dog barking. Okay. Stratified sample. A stratified sample is first breaking the population up into these characteristics that we're interested in, and then doing a simple random sample within each of those sectors. Convenience sample. Now, this is the most interesting picture of all. For this one, here's our population, but because it's a convenience sample, we are ending up with this kind of weird side group of the population that we are getting people from. And therefore, the problem with a convenience sample is it's not representing necessarily the population. And that means that we have potential for bias. So bias is when the sample does not accurately reflect the population. Now, it could be that that maybe the group of people who were participating in the sample is a problem. It could be that we did something wrong when we took our sample, like made a mistake as we were getting our information. But we'll talk more about that in depth in a minute. Let's look at some basic types of statistical studies. So we have two that we really focus on: observational studies, which is when we gather data without influencing the subjects. And wow, that's it's very sloppy, sorry. The subjects. An example of this would be researchers look at the health records of thousands of males to determine whether there was a relationship between family history and heart attack. So they're looking at existing documents, and they're using that data to figure out if maybe there's a connection between whether or not somebody had a heart attack and their family history behind that. What that means, though, is that we can only prove association between those two. So there is a connection. If they look at it and there's consistently people who've had heart attacks have this family history of heart attacks, that doesn't mean that you have a family history of heart attacks, you're going to have a heart attack. It doesn't mean that. It just means there's an association between that. An experiment is when data is gathered by exerting some sort of control over the subject. And the purpose of that is to measure a specific outcome. Now, it doesn't mean that, like, we're talking about has to be rats in a cage, right? Or anything like that. It could be something as simple as, do you prefer Coke or Pepsi? Here, try them both. That is an experiment, because I'm forcing people to try these two sodas and choose which one they prefer. Okay. Another example, or more scientific example, they want to investigate whether aspirin regularly reduces the risk of heart attack. 400 people who are identified as men are divided randomly into two groups. One group will take aspirin, one will just take a sugar pill. At the end of the study, they look to see, of those people who maybe had a heart attack after that 10-year period. So obviously they're probably in this kind of group of people who are prone to particularly heart attacks, probably 40s, 50s, 60s, and so forth. What's interesting about this is because they were given some sort of pill, it will prove causation. In other words, if the people who had aspirin definitely had heart attack at a less rate, that's provable. They've just proven it because the other group were forced not to take aspirin. They were given a sugar pill instead. So that leads to some more vocabulary here that we're kind of seeing, and we're just going to go quickly through defining. So the treatment group is the group receiving the treatment, That could be, in that last example, the group that's getting the aspirin, okay? And they're being measured, okay? The control group serves as a baseline. So in that last example, those would be the people getting the sugar pill. Now, the random selection means that we randomly assign treatment. Now, it's possible that it isn't always set up randomly, that there are specific things done in an experiment, but that is the idea, is that it's randomly assigning treatment. And you tend to do random like that when you have real issues controlling the group, meaning you can't have that much control over them, or there's a lot of outside factors that might influence the experiment. So random assignment helps kind of eliminate that issue. Okay, most people know what a placebo is. That's a fake treatment. The placebo effect is someone who has the placebo but are acting as if they received treatment. So a subject who receives placebo but is affected as if they received treatment. Single blind is when the subject doesn't know what treatment they are getting. Meaning they don't know if maybe they got the aspirin or the sugar pill, okay? Double blind is when both the subject and the researcher don't know. Which is useful when you're worried about maybe the researcher affecting the results. Both subject and researcher don't know treatment, assigned treatment. Oh, here, I meant to put treatment assigned up here. Let me add that word. Subject doesn't know treatment assigned. Both subject and researcher don't know assigned treatment. Okay. And then observational case controlled is subjects that are studied for a period of time or an extended period of time. So they're being studied for an extended amount of time. Okay, so let's kind of look at some examples. A group of disabled women age 65 and older were tracked for several years. That means they'd be in an observational case controlled. Ending in 2010, those who had a vitamin B12 deficiency were found to be twice as likely to suffer from severe depression as those who did not. So the two groups were in two categories. And the first one is that they have a B12 deficiency. And the second group is do not have B12 deficiency. And I'm sorry, my dog is in the background and making noise, and I hope that's not too loud. Oops, there's an E in deficient. Oh, that was an E. Deficiency. There we go. Okay, quick caution. This particular example is an observational study, which means it's association only. Okay. Not an experiment. Okay, so let's talk about confidence intervals and this idea of margin of error. Just a brief discussion about this. We're not going to get too heavily into this. So let's say we have a poll and 29% of hourly workers and 41% of salary workers say they're completely satisfied with the amount of money they earn, and that there is an error of 5% assigned to this, which means, and this is where the confidence interval comes from, that in general, the hourly workers, since 29% are satisfied, that really means that it's a range of 24, so 5% below 29%, so 24%, and then 5% above 29% to 34% are actually satisfied. So it's that big of a range of people. So could it be anywhere from 24 to 34% of hourly workers are actually in fact satisfied with their job. For salary workers, that would be as low as, so salaried workers would be then 5% below the 41, which is 36%, and all the way up to 46%, 5% above that. So that's what they mean by the confidence interval for this. Okay, so let's talk about bias. In general, bias is when there's an inclination towards something or maybe a prejudice against something. I'm not going to write that down, just kind of talking in generality. But in a statistical study, that can look a little bit different. In fact, these are the ways we have bias in statistical studies. So sampling bias, sorry, let me go ahead and talk to the dog here. Okay, sorry. So a sampling bias is when the sample is not representing the population. Voluntary response is when the sample comes from volunteers. And that's a problem because when you're volunteering, you might have a motive for volunteering. Self-interest, that usually means the researchers might not be the best people to be getting that information from. Response is when this person is inaccurate. Really, that means like, it's just not truthful. And so it's possible that it could be for many number of reasons. Not having an anonymity can cause a problem, loaded questions, and then of course, people not wanting to give an answer. So looking at this example, let's kind of go through and assign these based on that. So let's say a survey asks how many sexual partners a person has had in the last year. Well, there's a potential problem with this. And in fact, I would even consider that a couple different answers could work. If you're worried that maybe you might be judged by that information, you might be concerned that there's a perceived lack of anonymity. Okay, so that would be one potential issue or bias that might cause the person, sorry, let me spell anonymity correctly, that might cause the person to not want to be truthful. But then there's also a potential of just giving an inaccurate answer, which could be response bias in that case. And in my head, if this is an answer that you would give on a test, I'd probably accept either. Okay, so a radio station asks readers to phone in their choice for a poll. Well, that's a voluntary response. And whenever people are volunteering their answers, they usually have a reason. It's often because they're passionate and they care. But that means then they're kind of representing a minority of most people. Okay, substitute teacher wants to know how students did in a class. They asked the 10 students sitting in the front row. Okay, so we know that front rows typically represent often students who are wanting to be fully engaged. It could be for other reasons, but that might mean then that the scores are abnormally high. That could mean that we have a sampling bias, that the sample is problematic. High school students are asked if they consume alcohol in the last 2 weeks. Again, just like part A, this could be a response bias, or it could be a lack of anonymity. The Beef Council represents a study that consuming red meat. Okay, well, that's already a problem because self-interest, the people that who are interested in anything having to do with red meat are giving the information out, and that's not good. A poll asked, do you support a new transportation tax, or would you prefer that to see our public transportation system fail? Wow. Okay. Or fall apart. That's a loaded question. And that can happen. Questions can be written in a way that it kind of tells you what the person is hoping you will answer.